So we took before in the previous videos that if you have a parallel plate capacitor and the charge is Q and minus Q, and you insert the dielectric material keeping the charge the same. Remember, when you connect a voltmeter to capacitor plates, the voltmeter doesn't add or take any charge from the capacitor plates, an ideal voltmeter at least. We showed that the potential difference between the two capacitor plates is reduced by a factor of K. So now the question is, the initial capacitance is the charge Q over delta V node, the initial potential difference between the plates, and the final capacitance is the same charge divided by the new potential difference. Now the potential difference is reduced by a factor of K. So that means we can easily see that C is going to be equal to K times C node. Let's see how that comes exactly. So again, C node is the capacitance of the capacitor without the dielectric. So it has a value Q over delta V node. Delta V node is the potential difference between the two plates with no dielectric inside. And C is equal to Q over delta V. It's the same Q because the charge on the conductor plates stays the same, doesn't change. But the potential difference gets weaker, gets smaller because the electric field gets smaller. So let's see. C is equal to, for the case where the dielectric material is inserted, C is equal to Q over delta V, and delta V is delta V node over K. So the K will go up and you get Q over delta V node. What's Q over delta V node? It's just the original capacitance before you put the dielectric material. So we see that C gets increased by a factor of K. So the final result is that when you insert the dielectric material inside the capacitor, at constant charge, the capacitance of the device is increased by a factor of K. So this is the final result. The initial capacitance has a value C node. The final capacitance has a value K times C node. And the reason why the capacitance has increased is because the potential difference has decreased by a factor of K. The charge stays the same. So if you want to imagine what this looks like in the plots for the charge versus potential difference, this line is the line that you're living on when the dielectric material before it's inserted. So what does that mean? Whenever you increase the charge, the potential difference increases. By what ratio? By the ratio C node, which is the capacitance of the device. Okay, when you insert the dielectric material, what happens? You're inserting it at constant charge. So the charge doesn't change. But what happens to the potential difference? It decreases. So now when you reach this point, now when you have the capacitor with this new value, K times C node, however much you increase the charge on the capacitor now, after you've inserted the dielectric material, always you're going to be living on this new curve, where the slope is larger. The slope is far larger by a factor of K.